let's talk about graphing linear inequalities, right? So instead of an equal, we're going to have less thans and greater thans, right? Or maybe less than or greater than or equal to. Okay? So just like when we were doing linear inequalities in linear equations in one variable, and then we added the inequality bit and said, really, it's exactly the same with a little bit of an extension. You have to be careful when you multiply or divide through with a negative and change the direction of the sign. And then the way we leave our answer was a little different. Okay, so this is the same thing here. I'm just going to imagine in the beginning that this is just a regular equal sign, right? Just equals 6. Okay, now because my x and y are on the same side of the equation, I'm going to use my intercept method. So I'm going to let x be 0, and then I'm going to let y be 0. So if x is 0, okay, I would divide, and it's an equal, so I don't have to worry about this negative right now. I'm imagining an equal. I would divide by -1, divide by -1, divide by -1. So y would be -6. Okay. And then I'm going to imagine y is 0. So that would be divide by 3, divide by 3. So x would be 2. All right. So once I have my 2 points, I'm going to plot them. 0, -6, 1, 2, 3, 4, 5, 6, and 2, 0. All right, so it's exactly the same. It doesn't matter if that's a less than, greater than, equal to, or what. I find those 2 points by my same methods. Now, leaving the answers where it gets a little bit different. I have to decide if I do a solid line or a dotted. Remember when we had one variable, we had to choose between an open circle or a closed circle, depending on if we had the equal part. If we have the equal part, my line's going to be solid. Okay, so this is saying 3x minus y. I want the part that's greater than 6 or equal. And this line we just found right here is where it is actually equal. So I want that where it's equal. Okay, on this one over here, I'm going to find the 2 points, but then I'm going to make my line dotted. It's going to be the same thing as an open circle. Oh, not actually on the line. Everything else up to that line, but not on the line. Okay, and then I have to decide which side to shade. And in order to do that, I'm going to pick a test point. Okay, so I'm going to pick this point right here anytime I can, because that means I'm going to plug in a 0 and a 0. Right? That makes everything easy. So I'm going to put, this is when x is 0, y is 0. So if I go up here and I make that 0 and that's 0, I'm asking my question, is 0, here's the question, is 0 bigger than 6? Is 0 bigger? No. So that's not my answer side. Shade the other side. Okay, that's how I decide. All right. This one is set up perfectly to graph, and once again, remember, I'm imagining it has an equal sign. So it's set up perfectly to graph with the slope-intercept method. Now, if there's not a number over here, it means it must be 0. So there's my y-intercept. My slope is -1/3, so I can either go down 1 and over 3, or up 1 and backwards 3, just 1 in the negative direction. Okay, now it doesn't have the equal mark under there, so I'm going to make the line when I draw it dotted. Oh, sorry, you can't reach my phone. Okay, so I'm going to make the line dotted. Okay, now this line actually went through 0, 0. I cannot pick a point that's on the line, right, for checking. So you can pick any point you want as long as it's not on the line. If it doesn't go through 0, 0, I'm always going to choose that because it makes my math easy. But if it does go through 0, 0, I might choose like 1, 1. If you want to do 1, 0 or 0, 1, so one of them's a 0, that's fine. But if I do that, I had to be real careful of where I put my 0 and where I put my 1, which one's X, which one's Y. So I'm going to pick 1, 1, because then it really doesn't matter. They're both 1. So I'm going to ask myself, is 1 bigger than negative 1/3 times 1 would be negative 1/3. Is 1 bigger than a negative number? Yes, it is. So this is my answer side. Okay? All right, let's just try that a couple of more times. It's the same as graphing. We're just adding one small thing. So let's say we're going to graph 7x minus 2y is less than 14. It's set up perfectly for the intercept method. So I'm going to let x be 0 and y be 0. If x is 0, right, 14 divided by negative 2 times negative 7 would be y. If y is 0, all I have to do is divide by 7. 14 divided by 7 is 2. There's my 2 points. 0, negative 7. And 2, 0. Now my question is, do I draw a solid or a dotted line? I hope you said dotted because it doesn't have the equal part. So let's make this dotted, dash, dotted, whatever you want to call it. Not solid. Okay, and then I have to choose which side to shade. So I'm going to plug a 0 in for x and y. That would be 0. So my question is 0 less than 14? Yes, it is. That means this side has all my answers on it. Okay? One more. 5x plus 2 equals 7. Okay, what do you recognize about this, or what do you notice? Special, right? It only has an x, not an x and a y. So and I don't want equal. I want less than or equal. Okay, solve for x. 5x equals 5. So x equals 1. Okay, I keep putting equal and it's a less than or equal. Okay, x less than or equal to 1. Here's my x-axis. Here's the 1. Okay, so now I know, okay, it's a vertical line. Okay, and it is going to be a solid line because it has the equal part. And then I just have to decide which side to shade. Okay, this, because I'm only looking at x's, I know this is the side that's less than. But if I wasn't thinking about that, I'd still plug in a 0 for an x and a y. Of course, I only have an x, and ask myself, is 0 less than 1? Yes, it is. So this is the side I shade. Okay, graphing linear inequalities.